So the theme is going to be disproportionation reactions. There is nothing inherently new from the steps. If you have a reaction that is a disproportionation, you're going to put in all the oxidation numbers. You're going to figure out what gained, figure out what lost. What makes this unique or might seem weird is disproportionation is when you have the same atom acting as both the OA and the RA. Now, you're going to need more than one of them, okay? But maybe water is acting as the OA and the water and the RA. Or I'm going to do an example where copper plus 1 can do disproportionation. Copper plus 1 is going to be both agents. Copper plus 1 can disproportionate and make copper plus 2 and elemental copper. Now, I wrote in the 1 plus. We don't normally write in 1, but I wanted to emphasize the charge. So I'm going to, same type of concept, you're asked to balance this. I look, copper goes from plus 1 to plus 2. So that's going to be a 1 electron exchange. So there's 1 electron for every Cu. So 1 electron for Cu1 plus. And then if I go to keep going, it's like I already used that reactant. I only have one of them. But this is going to be that special disproportionation type where the copper plus 1 is going to be both types of agents. Sometimes what disproportionates is written twice as part of 2 different reactants. Here, I didn't write it twice. You need to realize that you need another one. And that's what can be tricky about disproportionation. There's a second reactant. We don't tell you how many you have to begin with. Okay, but if you think of disproportionation, you sometimes have to write it in. Copper 1 as plus can also turn into our other product, which is elemental copper. We don't put 0 charges in, but you have to realize that's 0. And that also happens to be a 1 electron exchange. Now let's do the gaining and the losing. The first copper plus 1 I had going to plus 2, that'd be going up to plus 2, so that's losing an electron. The far left copper 1 plus is going to gain an electron to make the elemental copper. Now, if we know what gained and lost, we can label each of them as an agent. So this one, in terms of an agent, it is losing an electron, so that's it's being oxidized, so it's the reducing agent. This copper is gaining, so that's being reduced, so this one is the oxidizing agent. The same type of species, the same element, or atom I should say, is acting as the OA and the RA. They don't always have to be the same charge. This example, they're both plus 1. We could see the element buried inside a bigger molecule. So now if we keep balancing this, we actually don't do anything else. First step is balance the electron exchange. This is also 1 electron for every Cu and 1 electron for Cu1 plus. Lowest common multiple between 1 and 1 is 1. So multiply both of these by 1, which we don't write the 1s in. Balance all the atoms. We have 2 coppers at the beginning, 2 coppers at the end. Balance the oxygen with water. There's no O's, so there's no water to add. And last, balance the H plus. There's no hydrogen, so there's no H plus to write. So that is actually it. It's a fairly simple redox reactions. You'd both label this as redox and you'd label it as disproportionation on an exam. you'll definitely be tested on the ability to label disproportionation. I'm not going to finish this, but something else that can disproportionate is water can react with water. We have water as a ORA near the top right of your table, and you have water as a OA way on the bottom left. Okay? So that would be another potential disproportionation, okay, that happens to be on your table. Okay? So anytime you have the same thing acting as both agents, okay, it's both redox and disproportionation. Well, I'm kind of on the topic of identifying types of disproportionation. You should realize that not everything is redox. All of our double replacements are not redox. So if you take silver sodium chloride and you add it to silver nitrate, in this double replacement, they're just going to switch partners. They're not going to switch any electrons. You're going to get sodium nitrate and silver chloride, which would precipitate. Silver chloride is not soluble. Now that is hard to identify as redox or not without putting in charges. But this is sodium plus, and it's still sodium plus at the end, so sodium doesn't gain or lose electrons, changes its partner. This is Cl minus, chloride, and we still have chloride. It precipitated, but it didn't change any electrons. We have silver plus, and we have silver plus. No electrons there, and NO3 minus, and NO3 minus. Neither the N nor the O changed any electrons. So this is not redox. So we just did disproportionation, which is both redox and the special category. But I'm ending with emphasizing that not everything is redox. Now I can give you a nice list of what is redox by reaction type. All of your single replacements have a compound and an element on each side. The element will always be 0, and the compound form on the other side will have a charge. So all of the single replacements are redox. We just looked at a double replacement, and none of those are ever redox. They're always just partner switches. If we look at combustion, combustion will have elemental oxygen, which is 0, and will always have water on the other side where it's -2. You'll find that combustion is always redox. You'll find formation and decomp, which are just opposites to each other, are also always redox, because you've got all elements on one side which are 0, and you've got a compound on the other, which will have non-zero oxidation states. So it's those double replacements that you have to watch out for not being redox. Now, Alberta Ed knows that most teachers are going to say this, so they're going to give you reactions that look like they're double replacement, but they're not. So just because you have two things becoming two things doesn't mean it's double replacement. You've got to actually watch the pieces to make sure it's just an ion switch. Okay? So look, you see something that looks double replacement, just do a little check and confirm before you answer that on a test.